Hi everyone, welcome back. Today we are solving maximum product of splitted binary tree. So in this problem, we will be given the root of a binary tree and we want to return the maximum product that we can get by splitting the binary tree into two subtrees by removing one edge such that the product of the sums of the two subtrees is maximized. So if we look at this example, to maximize the product, it would be best to do the split here. So this will have a sum of 11 and this subtree will have a sum of 10. 11 times 10 is 110. In this example, it will be best to split right here. So it will have a sum of 6 and 15. 6 times 15 is 90, so we return 90. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we will split into a few steps. The first step is we will use DFS or depth first search to find out all the possible sums of the subtrees. So if we have a tree, we will start from its root and we will search downwards. And as we go downwards, we will calculate the sum of all the subtrees and we will add it into an array to keep track of all the sums. And after we have done the DFS, we will calculate all the possible products by using this formula. The sum of the subtree times the total minus the sum of that subtree. So let's say we have a subtree, the sum of 11, we will do 11 times the total, which is 21, minus the sum of that subtree, which is 11. So that's how we can calculate all the products. And then after trying all the products, we will just return the largest product in the end. So let's go over this example real quick. This would keep track of all the sums of all the subtrees. This would be the total of the entire tree after we have calculated it, and result will keep track of the maximum products that we have seen. And this would be what we return in the very end. So first, we will look down to the left and then we get to here. This has a sum of 4, so we add 4 to sums. We look to this right. This has a sum of 5, so we add 5 to sums. Now we come back up, we will do the root plus the left and its right, so it will have a sum of 11, so we add 11 to sums. Now we will look to the right and now down to its bottom, it has a sum of 6, so we add 6 to sums. Then 3 plus 6, it has a sum of 9, and now it will add itself with its right and left. This will have a sum of 21, so we add 21 to sums and the entire tree will be the total. So now we can find the products by multiplying each number in sums by total minus that number. So 4 times 17 would be 68, larger than result, so we update it. Look to the next one, 5 times 16, and we get 16 because 21 minus 5 is 16, it's 80, so we update result to 80. Look to next one, 11 times 10 is 110, so we update result to 110. Look to the next one. 6 times 15 is 90. It's not larger. Try the next one. 9 times 12 is 108. Not bigger. So we try the last one, which is the total. 21 times 0 obviously will not be bigger. So we will return 110 as our result. And the time complexity will be O of n, where n is the number of nodes in this tree, because that would be the number of nodes we will have to search through. And the space complexity will also be O of n, because this sums array can take up to n space, and also the DFS recursion stack can also take up to n space. So now let's get to the coding part. So first we will set up the sums to an empty array, and then we will define the DFS function. So if it is not null, we just return 0. Otherwise, we will look to the left and we will also search to the right, and we will calculate the total, which would be the left side plus the right side plus the value of the node itself, and we will add the total to sums and return the total for the function. So we will get the total sum of the entire tree from DFS of root, and we will initialize result to 0. And now we will look through all the sums. So for S in sums, result would be the max of result, or sum times total minus sum. And finally, we can return result, but we also need to modulo it by 10 to the 9th power plus 7, because that's what the problem description says. Okay, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.